video is the first part of the topic 4, where we will talk about chemical equation and stoichiometry. In chemical equation, we will talk about balancing equation, and in stoichiometry, we will be doing some calculations. For this video today, the part 1 of it, we will talk about oxidation number. Before we go into the chemical equation, we need to know what is the oxidation number, whether the oxidation number increases or decreases. Oxidation number and charge. What is the main difference between oxidation number and charge? A very simple example, if I have oxygen, and you all know that oxygen having a 2 minus, and the 2 minus over here is what we call charge for oxygen. But the oxidation number will be -2. So the main difference between the oxidation number and the charge is the way of writing. The oxidation number, the symbol positive and negative will come first, while for the charge, the number will be coming first. Let's look into another example. For example, chlorine. So we know that chlorine is a Cl minus. So for the charge is actually 1 minus. For the oxidation number will be -1. How about magnesium? If I have a magnesium, we all know that magnesium charge is a Mg2+. So the charge will be 2+, while the oxidation number will be +2. So always remember, for oxidation number, the symbol always comes first before the number. For the charge, the number comes first before the symbol. Oxidation number is actually the number assigned to each element in a compound. So each element in a compound will have an oxidation number, depends on the amount of electron that being accepted or donated. But if you look into a very simple example that I have over here, look at the carbon that I have in this compound and the carbon that I have in carbon monoxide. You can see that the oxidation number changes from +4 to +2. And if you look at the carbon over here, it's a -3. So why the oxidation number of carbon is different? And if you look at the hydrogen over here, the hydrogen is +1. The hydrogen over here is -1. Why the oxidation number changes? Chlorine. We all know that chlorine is a halogen that will normally be -1. Why the chlorine over here is +5? Why the chlorine over here will be +4? So we will look into how to determine the oxidation number. We have some tips and some basic rules to determine what is actually the oxidation number of the element in a particular compound. The first and foremost, element with itself will be having an oxidation number of 0. Group 1 metal will always be holding +1. Group 2 metal will be always holding +2. Fluorine, your halogen, will be always -1. Halogen, the rest of the halogen like bromine, chlorine, iodine, will be -1 normally, but the halogen of Br, chlorine, and iodine will be positive when they come with oxygen. Oxygen will normally be -2, but it will be in -1 when it's with peroxide. While hydrogen can be +1 and can be -1 depends on the partner. If the hydrogen is sitting with non-metal, then the hydrogen will be +1. If the hydrogen sitting with a metal, then the hydrogen will be -1. Another rule is the sum oxidation number for a neutral compound will be 0. Another one, the sum oxidation number for polyatomic ion will be the charge of the ion. Don't worry about this. I will show you example for every single tips and rules. Let's go to the first example. We have sodium, barium, chlorine, ozone, and phosphorus. And if you look at it, all of them are elements by themselves only. So if you're having element by itself, every single one of them will having an oxidation number of 0. So, no matter they are atom or they are molecule, as long as we are only having single type of element, there will be oxidation number 0. The second example that I have is sodium chloride. If you look at here, we know that sodium is a group 1 metal. So we will look into group 1 metal. And you know that chlorine is a halogen. And halogen, we have -1 or positive. It will be -1 normally, but positive when with the oxygen. Do I have oxygen? No, I don't. So, halogen right now is in a normal condition. And if you look at here, your sodium should be a +1. Your chlorine should be a -1. How do we prove this oxidation number? The sum oxidation number for a neutral compound is 0. This is a neutral compound. There is no charge. Therefore, the oxidation number of sodium plus chlorine must be equals to 0. Sodium, we know that is a +1. Chlorine, we also know that is a -1. Therefore, the +1 plus -1 will be equals to 0. So it's proven that your sodium is +1, your chlorine is -1. Lithium oxide. Lithium, again, is your group 1 metal, and that is your oxygen. So your group 1 metal, again, the group 1 metal must be +1. Oxygen will be normally -2, but it will be -1 in peroxide. But we don't have peroxide, so your oxygen right now will be in -2. So oxygen -2. It's a neutral compound or it's an ionic compound? It's a neutral compound, so addition of them must equals to 0. Lithium, we have 2 lithium, so 2 times of lithium plus oxygen will be equals to 0, neutral compound. So lithium holding a +1 plus with the oxygen holding -2. Therefore, it will equals to 0. It's proven that your lithium is +1 and your oxygen is -2. Barium fluoride. And in here, if you look at it, we have fluorine and we have barium. We know that fluorine stated very clearly, fluorine must be -1. So, what would be the barium? We know that it's a neutral compound, so it must be equals to 0. So, barium plus 2 fluorine must be equals to 0. How much would the barium be if I have fluorine is -1 equals to 0, and therefore barium will be equals to +2. Let's check whether is that true barium should be +2. Barium is actually a group 2 metal. When barium is a group 2 metal, barium should be a +2. So again, it's proven that your barium is +2, your fluorine is -1. Next, calcium oxide. So again, how much would be the calcium and how much would be the oxygen? If you look at here, calcium again is your group 2 metal. Therefore, your calcium should be a +2. Your oxygen over here is not in peroxide. Therefore, your oxygen is in -2. And to prove that right, we just need to add it up and it must equals to 0 because it's a neutral compound. So your calcium holding +2, your oxygen holding -2, obviously equals to 0. And that again proves that your group 2 metal must be +2, your oxygen will be -2 when it's not in peroxide. Next, we have ammonia. If you look at ammonia, we have nitrogen and we have hydrogen. So hydrogen can be +1, can be -1. It will be +1 when it partners with non-metal. It will be -1 when it partners with metal. So nitrogen obviously is a non-metal. And therefore, in this case, hydrogen must be positive 1. And if you look at nitrogen, none of our rules mention about nitrogen. So how do we know nitrogen? That is the case where calculating oxidation number is important. So we can work out the oxidation number of nitrogen by using the rules above. Hydrogen must be positive 1 when it's with non-metal. The neutral compound must equals to 0. So I have nitrogen, the one I'm looking for, plus I have 3 hydrogen. N is a neutral compound, therefore it must equals to 0. Nitrogen is the one that we are looking for. We know that in this case, hydrogen is a positive 1. And then we work out the mathematics. So you have positive 3 equals to 0. And therefore, nitrogen will be equals to negative 3. Next, aluminium hydride. Aluminium, again, is something that is not mentioned above. None of the rules above mention about aluminium. So we need to find out the oxidation number for aluminium. How about hydrogen? We have the rules about hydrogen. Non-metal or metals. Aluminium obviously is a metal. So your hydrogen right now must be negative 1. And again, your aluminium hydride is a neutral compound where the total oxidation number must be equals to 0. So you have aluminium plus 3 hydrogen equals to 0. You can solve out the mathematics and you realize that your aluminium is positive 3. So the oxidation number for aluminium will be positive 3 in this case. Next, BrO3 minus. So we will see how the calculation of oxidation number goes. Br is a halogen, and we know that halogen can be negative 1, halogen can be positive when with oxygen. So your Br right now is sitting next to oxygen. Therefore, your halogen must be positive right now. But positive, how much? It only stated positive, but we doesn't know positive how much. Oxygen. Oxygen will normally be negative 2, except in peroxide. So this one is not in peroxide. Your oxygen right now is negative 2. And this is an ionic compound. Therefore, the total oxidation number must be equals to the ionic charge. And we can work it out. Br is the one that we are looking for. I have 3 times of oxygen and it must equals to negative 1. The total oxidation number must equal to the charge. So Br is the one that we are looking for. Oxygen is a negative 2 and Br will be positive 5. And you can see over here, halogen will be positive when with oxygen, and Br right now is in positive 5 oxidation number. Sulfate ion. So you have SO4 2 minus. Again, it's a polyatomic ion. Therefore, the total oxidation number must equals to the ionic charge. And sulfur is something that we did not mention at all above. So sulfur will remain an unknown. We do not know how much sulfur should be. But oxygen will again be negative 2 because it's not in peroxide. So work out the mathematics. Sulfur plus 4 times of oxygen equals to negative 2. Sulfur is the one that we are looking for. Oxygen normally will be negative 2. Total of the oxidation will be negative 2 because of the charge. So work it out. Sulfur will be how much? If you solve the mathematics, you realize that your sulfur is positive 6. And therefore, the oxidation number of sulfur in sulfate ion is positive 6. Next, we have peroxide finally. So you have your H2O2 over here. You have your hydrogen and oxygen. but your oxygen right now is in peroxide. And your hydrogen is with the non-metal. Obviously, oxygen is a non-metal. So by right, the hydrogen over here should be +1. The oxygen over here should be -1. We will check this, or we will prove this by using the total of it must equals to 0 because it's a neutral compound. So we have 2 hydrogen plus with 2 oxygen, and it must equals to 0. According to the rules, hydrogen is +1 in this case, while oxygen is -1 in this case. And if you work out the mathematics, you realize that they will equals to 0. And it's now proven that the rules above is correct, where the total oxidation number for the neutral compound must be 0. The hydrogen with the non-metal must be +1. The oxygen in peroxide must be -1. Next, we have ClF3. If you look at this compound, both elements are actually halogen. One is chlorine, one is fluorine. But how do we know which one is how much, which one is positive, or which one is negative? We will check based on the rules. If you look at the rules, your fluorine must be -1. So your fluorine over here must be -1. Since your fluorine must be -1, how much would be your chlorine? And it's a neutral compound. So the neutral compound, the total oxidation number must equals to 0. So we can work it out. You have your Cl plus 3 times of your fluorine must equals to 0. Chlorine is the one that we are looking for. Fluorine must be -1. And the total must equals to 0. Your chlorine will then be +3. So the oxidation number of chlorine over here will be +3. Although it's not with the oxygen, but your halogen right now is with fluorine. Therefore, your halogen also will become positive. Next, KMNO4. And in this KMNO4, which one will be unknown? K is a group 1 metal. Oxygen is stated above. So we know that group 1 metal must be +1. Oxygen will normally be -2 except in peroxide. So in this case, it's not peroxide, therefore oxygen will be -2. But manganese, do you know anything about manganese? No. So manganese will be the unknown that we are looking for. Again, it's a neutral compound where the total of the oxidation number must equals to 0. So the calculation will look like this. Potassium plus manganese plus 4 times of the oxygen must equals to 0. Potassium must be a +1. Manganese is the one that we are looking for. Oxygen is -2. Total must be 0. Solve the mathematics. Your manganese will then be +7. Next, Na2Cl2O7. So Na again, group 1 metal. Oxygen again is not with the peroxide. Therefore, your sodium will be a +1. Your oxygen will be a -2. Your chromium will be unknown. But be careful because we have 2 chromium over here. So work out the mathematics. Your Na must times 2. Plus with 2 times of the chromium plus 7 times of the oxygen and must equals to 0 because it's a neutral compound. Therefore, the total oxidation number must equals to 0. Sodium is a +1. Chromium is the one that we are looking for. Oxygen must be -2. So solve the mathematics. Since we have 2 chromium equals to +12, but the question only asking for chromium. Therefore, it will equals to positive 6 only. So your chromium oxidation number will be positive 6. Remember to divide by 2 because we have 2 times of the chromium. Next, we have H2PO4 minus. So over here, which one are we looking for? Hydrogen, we have it in the rows. Oxygen, we have it in the rows. Hydrogen is with non-metal right now, so hydrogen will be positive 1. Oxygen will normally be negative 2 unless it's in peroxide, but it's not in peroxide right now. So obviously, we are looking for phosphorus. How much will be phosphorus in here? And it's a polyatomic ion, therefore the ion charge will be equals to the total of the oxidation number. So we have 2 hydrogen plus with 1 phosphorus plus with 4 oxygen equals to negative 1. So your hydrogen over here is positive 1 as agreed before. Phosphorus, we are looking for it. Oxygen is negative 2. Total must equal to the charge negative 1. And therefore, your phosphorus will be plus 5. Your oxidation number of phosphorus over here will be positive 5 in this compound. And that's it about this video on oxidation number. I hope oxidation number right now is easier with all the rules given above. And it's pretty simple. Do not do silly mistake on your simple calculation. And I'll see you again in the next video. Have a good day.